Okay, so for example number 3, again, I've written out the vertex form so that we can see it. So we have A equals 2 in this case. And so we have H equals -1, and we have K equals -2. So we know that our vertex is at -1, -2. So it's right here. But we have a slope, because we're stretching it, we have a vertical stretch of 2. We're going to rise 2, run 1. So rise 2, run, and of course the left side is a negative, so we're going to rise 2, run -1. On the right side it's positive, so we rise 2, run +1. And again, we've stretched it along the y-axis, so we have a vertical stretch. Okay, had we not had the 2 and it was just, there was no 2 there, it was just a 1, we would have had this for our graph. So you can see the difference here in that we've stretched it up the y-axis. So here in example 4, we have A equals -1, okay? And we have H equals +6. We have K equals 0. So our vertex is going to be at 6, 0, which is right here. Now the left-hand side, because we have a -a, a -1 for A, our left-hand side is actually going to be rise -1, run -1. So we're actually going to have a positive slope on the left side this time, and we're going to have a negative slope on the right side. And we can't draw it too much further than that. And we always want to have those arrowheads there. Okay, here we have A equals 2/3. So since 2/3 is less than 1, we're going to end up with a compression. So it's actually going to be fatter, if you will, than the parent function. So we have A equals 2/3, we have H equals -1, and we have K equals -1. So our vertex is going to be at -1, -1, so it's going to be right here. And now we're going to rise 2, run 3. So when we rise 2 and then run 3, run 3, let's get rid of that other one. Rise 2, run 3, notice it's getting a little fatter. So we're going to rise 2, run 3, and it's kind of laying down. It's being compressed along the x-axis. So we rise 2, run 3, rise 2, run 3, and now we can draw our lines in that direction and then in that direction, and you see it's gotten a little fatter. Had we had a 1 as our A, it would have been rise 1, run 1, rise 1, run 1, and you see that it would have been along the black line. But now that we've got something smaller than 1, we've compressed it and pushed it down so it's kind of wider. Had we had something greater than 1, we would have had something that looks more like this, and that's a vertical stretch. So we either have vertical compression, depending on what A is, or a vertical stretch. And so if A is greater than 1, we have a vertical stretch. If it's less than 1, we have a vertical compression. So in this case, we had vertical compression. The blue line indicates the graph for this particular function. Okay, so I'm only going to do one more, number 6, because the other ones are piecewise functions. So we're going to look at this, and so we have A is equal to -3/4. So again, we have A is less than 1. Now it's really A is less than the absolute value of 1. And because the negative just means we're flipping it upside down. So we're still going to have a vertical compression. It's going to be flipped upside down. The input didn't change, so H equals 0. The output did change, so K equals +7. So our vertex is going to be at 0, 7, which is right here, I do believe, 1, 2, 3, 4, 5, 6, 7. Okay, and now it's going to flip upside down because A is negative, but we're going to go down 3 over 4, and down 3 over 4. And so we can draw that side, and again we're going to go down 3 over 4, down 3 over 4, and we have the right side. And so we can tell that we've kind of flattened it out. It's gotten fatter, wider, if you will, than if we had had a -1 for our A. So if we had had a -1, we would have been traveling along like that and here. That would have been that. So again, we've flattened it or made it wider because we have an A that has a value less than 1. So on -9, I've graphed it for you. I've graphed the equality, but notice that this is an inequality. So now we have to decide which way are we going to shade. Okay, so I already have the graph of absolute value x plus 4 all minus 6, and you can confirm that I've graphed it correctly, but now we've got to decide what side is shaded. Do we shade above the absolute value, or do we shade below the absolute value? So we can still do something just like we've done in the past with shading inequalities or graphing inequalities, is do the 0, 0 test. So if the 0, 0 test means that y equals 0 and x equals 0. And that point, if you recall, is right here. There's that point, and we want to see if it makes a valid statement. Because if it makes a valid statement, then that means that that particular point right here is part of the solution set. So we're going to substitute 0 in for our f of x, which is the same thing as y. So we're going to say 0 is less than or equal to. Now we're going to substitute 0 in for our x, the absolute value of 0 plus 4 minus 6. So now when we do this math, we'll know that notice that the absolute value of 0 plus 4 is just 4. So we have 0 is less than 4 minus 6. So 0 is less than -2. Since that is not an accurate statement, because 0 is not less than -2, we know that 0, 0 is not part of our solution set. So we're going to shade below the absolute value graph. And if we make the graph long, we'll see that all of that is shaded. So I'm going to leave example number 10 for you to figure out, and you need to bring it to class with you.